Hi students, good morning to all. Today we are going to discuss the next concept called backward chaining. So already we discussed forward chaining. In the same manner it is called backward chaining. So now come to the first point, forward chaining. Forward chaining applies a set of rules and facts to deduce whatever the conclusion can be derived. So when you want to derive a conclusion from any problem or anything, the forward chain applies a set of rules and facts to deduce conclusions and to derive that from the proofs. So in the same manner, backward chaining is also another concept. So backward chaining is an inference method that can be described as working backward from the goal or conclusion. So forward chaining means it moves forward direction, starting to end. But a backward chaining means it moves from end to starting. That means from goal to starting point. Backward directionally it will be started, or it describes its concept. So that is nothing but backward chaining concept. So this algorithm works backward from the goal, chaining through rules to find known facts that support the proof. So with the help of backward chaining algorithm, we move in the backward direction. That means start from the goal and move forward to the starting point. So when you moving or chaining like that, the rules will find the known facts which are support to the proofs. So to prove this concept, so in the forward chaining also we taken an example that nothing but that American and Nunu country weapon sailing concept, we proved that one. So in the same manner, to prove any concept with the help of the rules, we are finding the known facts in is the concept in backward chaining. But how we are knowing means we are starting from goal to starting point. So in the backward format, we are moving to find all the facts which are support for the proofs. The next point is it is used in automated theorem provers, inference engines, proof assistants, and other artificial intelligence applications. So these backward chaining concepts are used in different places, mainly automated theorem provers. So generally in our mathematics or in statistics or in operation research environments, what are the theorems are there, those manually we are proving. But so these backward chaining concepts, such type of things are used in the place of automated theorem proving environments. Automatically the theorems are how it is proved. So it is proved automatically in such an environment. And inference engines, so already in the backward chain forward chain concept we discussed the inference engine concept there also, and proof assistance. So to prove anything in their places also, and other artificial intelligence applications environments, the backward chaining concepts are used. So mostly the backward chaining and forward chaining, two different concepts are there. In that forward chaining, moving the forward direction from starting to goal. So finding the rules, facts and everything, and finally concluding the conclusions. So it is comes under forward chaining. And when you come to the backward chaining, reverse of the forward chaining, it moves from goal to starting point and finding what are the required rules and facts to support the proofs. So all these things will be done here. And where the these backward chaining algorithm mainly used means automated theorem proving environments and inference engine place and proof assistant environments and some other artificial intelligent applications environments also we are using backward chaining concept. The next one is in game theory. So we already said some different places, artificial intelligent environments, and some other different places we are using backward concepts. So in that example is first we are used in game theory. So in game theory, its application to sub games in order to find a solution to the game is called backward induction. Backward induction. That means in the game theory, to solve the game problem, what we are doing means its application, that means backward chaining applications, divides them into sub games in order to find the solutions to the games. So always in the DBMS we discussed normalizations. So in the normalization, to get a table into a normal form means the very first concept is divide the table and make them into small pieces. Small concepts can easily solve the problem. So in the same manner, in the game theory also, the backward chaining applications simplify them, simpler. That means subdivide the games into sub games in order to find the solutions to the games. So if you subdivide, you can easily identify the solution for each game. So in this manner, if you make them into sub-growing sub-parts and find the solutions, all these similar simple concepts are comes under backward induction concept. So in game theory, so to make them to solve the problem and find the solution to the games are called as backward induction concept. Then second example in chess. So computer chess. In chess, it is called intrograde analysis. So in game theory, so this backward chaining concept we are calling as backward induction. When you come to the second example, chess. In chess, it is called as intrograde analysis, and it is used to generate table basis for chess end games for computer chess. So where we are using this backward chaining concept in chess means computer chess environment. So generally it is used to generate table based chess concepts. So in the computer chess environment, these backward chaining applications are called as intrograde analysis concepts. Then when you come to both, rules are based on modus ponens inference rules. So these backward inductions and intrograde analysis, these both rules are also comes under modus ponens inference rules only. That's why only we already discussed that modus ponens inference rules in our previous concepts of modus ponens. So the modus ponens mainly discussing two things. One is if then rule and second one is inference. In the inference rules we are discussing about substitutions. So if you make substitutions, then two sentences may become identical. So that the 2 points the modus ponens rule will say strongly. So both rules, the game theory concept and the intrograde analysis concept, both rules are based on modus ponens inference rules. So in the backward chaining algorithm also we are using this substitution concept. Why? Because means it follows modus ponens inference rules. So substitution is one of the concept in modus ponens. That's why I use that concept in algorithm also. Now come to the algorithm for backward chaining. So this is the simple backward chaining concept. Nothing but we are using substitution here. So function backward chain. The function is backward chain. What are the variables is there? So from where we want to take the data, we want to move backward. So already it is developed. So it is stored in the knowledge base, comma, what we want to find, Q. So a set of substitutions, returns a set of substitutions. Then backward chain list. So knowledge base, Q and empty. First starting the list is empty. Then come to starting of the algorithm. Function backward chain list. So knowledge base, so Q list, comma, that substitution here. So we taken the some substitution concept, returns a set of substitutions. Okay, input is knowledge base, then Q list and some substitution, current substitution value, maybe anything. So these three concepts are nothing but the inputs we are taken. And what is the status now? Answers, a set of substitutions initially empty. So at the initial state of the backward chain, substitutions are empty. We are not substituted anything generally. So if, so already modus ponens, it says two concepts. One is substitution concept and if then rules concept. So substitution is there, and if queue list is empty, then return 5. So if queue list is empty, what is the return? Nothing is returned. So if it is not, else queue implies first queue list. So first, some in the queue list, some variables must be there for each q of I dash in knowledge base, such that phi of, so if it is empty means 5, if it is a value is there means phi of I, that implies unify q comma q of I dash succeeds to add compose phi comma phi dash to answer. Then the same, so already in the modus ponens, what is the concept we discussed? It will be given here, the sentence will be discussed. P of p comma a and so on, a of p of n, which implies q of I in knowledge base. So this is the sentence we are taken from knowledge base. Okay, and succeed to give the answers. So backward chain, back chain list, knowledge base, comma substitution. What is the substitution here? We are taken phi of I comma p of and so on, p of n, comma compose. So here we have composed the concept, compose of phi comma phi of I union of answer. So what is the answer we have discussed? So get here, that union must be given here. Finally, it returns the union of back chain list knowledge base, rest of q of list comma, the same points will be given here. So this is the concept of algorithm for backward chaining algorithm. So nothing is there. So backward chain function will be there, and initially what is the inputs it will be taken. So this function we want to remember, back chain list. Inputs are knowledge base, q list, comma some substituting variables, returns some set of substitutions. Then inputs, same points will be again, knowledge base, q list and some inputs. So what is the status? We want to find the answer as some set of substitutions. Initially the substitutions are empty. Then, so modus ponens means if then rule. So if q list is empty, then what is the list is also empty. Then we want to find the q list. So q of first q list. So the q list we want to find here with the help of these sentences. So some of the points we can easily remember in the algorithm. Repeatedly they are given these steps or only these functions we want to remember. So this is the concept of backward chaining. Then now we are here, we are taken an example in step by step manner. So already we solved the forward chain concept. Forward chain concept. How we have solved the forward chain concept? We are starting to find that West as a criminal. So that is the end. Finding West colonel is a criminal. But here we are starting from criminal West. So it is a backward. So that's why we start here to find the concept. So we want to say criminal, colonel West is a criminal. For that what we want to do means, so he want to sell weapons to the hostile country, that is no country. So this Western is nothing but a American, and he have weapons, and those weapons he sell to hostile country. So with the help of this we find these things, and from these things we want to find the other things. So weapons means what type of weapons? From America there is no things are there. American, he is simply an American, that's all. But weapons means what type of weapons? Missiles. So those missiles we sell to the hostile country. Then if you come to here, so those who, so when you come to sell, So what he said, missiles to whom? No country. We sell this concept to the no country. So in the from conclusion to we start our derivation. So we derive in this format. So backward direction. This is the goal, and we started from the goal and move backward direction. So this is a simple example for backward direction. But in the previous concepts, we started from the starting place. So American, so who is a Western, like that, and from there to we prove that Western colonial is a criminal. We stopped in this stage. So that is forward chaining, and this is backward chaining. So this is the concept of total construction of your diagram. So here finally we concluded that this criminal, Colonel West is a criminal. So this is the concept of backward chaining. Thank you.